The problem facing the 8th Air Force in 1943 was as frustrating as it was dangerous. American heavy bombers flying at 25,000 feet over occupied Europe encountered weather conditions that made precision bombing nearly impossible. Dense cloud cover stretched across the continent for days at a time, obscuring targets and forcing mission planners to scrub countless operations. The bombers had been designed to strike with accuracy in clear conditions, but European weather rarely cooperated. Crews would arrive over their targets only to find nothing but an impenetrable blanket of white below them. Strategic bombing doctrine demanded accuracy. The Americans had committed themselves to daylight precision bombing, distinguishing their approach from the British area bombing campaigns conducted at night. This meant hitting specific industrial facilities, rail yards, oil refineries, and aircraft factories rather than carpet bombing entire cities. But precision required visibility, and visibility was exactly what the weather refused to provide. Bomber crews could navigate to the general vicinity of their targets using dead reckoning and radio aids, but actually seeing what they were supposed to destroy proved far more challenging than anyone had anticipated. The standard heavy bombers of the era, the B-17 Flying Fortress and B-24 Liberator, carried the Norden bomb sight. This sophisticated optical instrument could theoretically drop a bomb into a pickle barrel from 4 miles up, at least according to the promotional materials. In reality, the Norden required a clear view of the ground and a steady bombing run to achieve anything close to its advertised accuracy. Clouds made it worthless. The bombardier would peer through his sight and see nothing but gray mist. Some crews attempted to bomb through breaks in the clouds, but results remained poor. Tons of high explosive fell on open fields and forests, while the actual targets continued operating unmolested. The Lockheed P-38 Lightning entered this problem as an unlikely solution. The Lightning had earned its reputation as a capable long-range fighter with its distinctive twin-boom design. Its twin engines provided redundancy and power, while its tricycle landing gear made it easier to handle on the ground than conventional tail draggers. The central nacelle housed the pilot and all the armament, creating a concentrated cone of fire without the ballistics problems of wing-mounted guns. By 1943, P-38s were escorting bombers deep into German territory, their range exceeding that of the P-47 Thunderbolt. Someone in the 8th Air Force had a revelation. The P-38 was fast enough to keep pace with bomber formations, possessed the range to accompany them to distant targets, and had room in that distinctive nose for something other than guns. What if they removed the armament and installed a bombardier station instead? This modified Lightning could fly at the head of a bomber formation, its bombardier using a Norden sight to locate and aim at the target. When the Pathfinder P-38 released its bombs, the entire formation behind it would drop their loads simultaneously. One skilled bombardier in a nimble fighter that could penetrate weather fronts more easily than lumbering bombers would guide hundreds of tons of explosives onto target. The concept required significant modifications to the Lightning. Engineers began with the nose section, which normally contained 4 50 caliber machine guns and a 20mm cannon along with their ammunition. All of this had to go. In its place, they installed a plexiglass nose cone, not unlike the transparent nose sections of the bombers themselves. This created a station where a bombardier could lie prone, just as he would in a B-17 or B-24, operating his Norden bomb sight with an unobstructed view forward and downward. The modified nose drooped slightly to improve the bombardier's visibility, giving the aircraft its memorable nickname, the Droop-Snoot. The name captured the ungainly appearance of what had been a sleek fighter, now sporting a bulbous glass proboscis. The modification transformed the P-38 from a predator into a guide dog. Instead of the original single-seat configuration, the Droop-Snoot became a 2-man aircraft. The pilot still sat in his normal position in the central nacelle behind the new nose section. The bombardier occupied the modified nose compartment, lying flat on his stomach for the bombing run, with his face pressed to the Norden sight. Communication between pilot and bombardier became critical. The two men needed to coordinate closely during the final approach to the target. The bombardier would provide directional instructions, calling for small course corrections to line up the sight properly. The pilot had to maintain steady speed and altitude, fighting the natural tendency to jink and weave that fighter training had burned into his reflexes. Any deviation would throw off the bombardier's calculations. This required discipline and trust, with the pilot essentially surrendering control of the aircraft to the man lying in the nose during those crucial moments over the target. The Droop-Snoot carried its own bomb load, typically a pair of 1,000-pound or 2,000-pound bombs. This wasn't intended to add significantly to the destructive power of the mission. Rather, the bombs served as ballast to keep the aircraft's weight and balance similar to a standard P-38, and more importantly, their release provided the signal for the formation to drop. The bombardier in the Droop-Snoot would track the target, make his adjustments, and hit his release. The bombs falling away from the P-38 were the cue every bombardier in every bomber behind was watching for. When they saw those bombs drop from the leader, they toggled their own releases immediately. The procedure required extensive training and coordination. Bomber crews had to learn to follow the pathfinder precisely, maintaining position in the formation despite weather and enemy action. They had to trust that the bombardier in that strange-looking lightning knew what he was doing. The Droop-Snoot crews themselves needed special training. Fighter pilots weren't accustomed to flying steady, predictable courses through flak, and bombardiers weren't used to working in cramped fighter cockpits. The learning curve was steep, but the potential payoff justified the effort. Weather reconnaissance became a crucial part of Droop-Snoot operations. Before a mission, weather aircraft would scout the route and target area, reporting cloud conditions, tops, and breaks. Mission planners would use this information to determine if conditions favored a Droop-Snoot-led attack. The Pathfinder P-38s could climb above most weather systems or find ways through them that would be dangerous or impossible for bomber formations. They could pop out of clouds closer to the target, giving the bombardier just enough time to locate landmarks, identify the aiming point, and set up his bombing solution before the formation behind him emerged from the overcast. The technique worked best with what crews called bombing through overcast missions. In situations where clouds covered the target but the formation could fly above the cloud deck in clear air, the Droop-Snoot would descend below the clouds or use brakes to spot the target. The bombardier would make his calculations based on what he could see, accounting for wind drift and the time it would take for bombs to fall through the cloud layer. When he released, the bombers above would drop their loads based on his timing, hoping that the calculations were correct and that the bombs would hit home somewhere beneath the clouds. Other missions employed a different approach. The Droop-Snoot could lead the formation through cloud layers, using its smaller size and maneuverability to navigate safely. Once through the weather, the formation would be positioned for a clear bombing run. This was particularly valuable in European weather patterns, where cloud decks often had definite tops and bottoms rather than extending indefinitely. The lightning would punch through, orient itself toward the target, and the bombers would follow in its wake, emerging from the clouds already lined up for their attack. The H-2X radar system equipped some Droop-Snoots, adding another dimension to their capability. This ground-mapping radar allowed the bombardier to identify terrain features and built-up areas even through complete cloud cover. The radar display showed cities as bright returns against darker countryside, and experienced operators could identify specific targets by their radar signature. Rivers, coastlines, and major rail yards produced distinctive patterns on the scope. A Droop-Snoot with radar could lead formations when weather made visual bombing completely impossible, essentially conducting radar-guided attacks with the precision of a specialized pathfinder bomber, but with the speed and agility of a fighter. German defenses had to adapt to this new threat. Flak gunners found the Droop-Snoots harder to track than the standard bomber formations. The pathfinder would appear suddenly, moving faster than the heavies, and the psychological impact of seeing a fighter leading a bomber stream was significant. Fighter pilots received instructions to prioritize shooting down pathfinders if possible, recognizing that destroying the leader would disrupt the entire mission. But the Droop-Snoot's performance made it a difficult target. It could accelerate away from danger or maneuver more aggressively than any bomber while still accomplishing its mission. The first operational Droop-Snoot missions flew in early 1944. The 20th Fighter Group received modified P-38s and began training their crews in the new pathfinding techniques. Initial results were mixed, as crews learned the complexities of coordinating a fighter with a bomber formation. The Lightning's higher speed meant constant throttle adjustments to avoid overrunning the bombers. The bombardier had to work in a more confined space than he was used to, and the vibration from the twin engines made the Norden sight more difficult to use precisely. But the problems were solvable. Pilots learned to fly formation with the bombers, matching their speed and altitude perfectly. Bombardiers adapted to the cramped nose compartment and developed techniques to compensate for the additional vibration. More importantly, the concept proved itself. Missions that would have been scrubbed due to weather could now proceed. Targets that had been impossible to hit through cloud cover were suddenly vulnerable. Mission reports from spring 1944 documented the effectiveness of the Droop-Snoot concept. Bombing accuracy improved measurably when Pathfinder P-38s led formations compared to missions where bombers had to navigate and bomb independently through weather. Targets that would have been impossible to attack in certain weather conditions became viable objectives. The 8th Air Force could maintain operational tempo even when European weather tried to shut down strategic bombing. This kept pressure on German industry and denied the enemy respite during periods when weather had previously provided a shield. The men who flew these missions faced unique challenges. Droop-Snoot pilots were fighter jocks at heart, trained for aggressive maneuvering and air combat. Flying straight and level through flak concentrations went against every instinct. They had to suppress the urge to jink and weave, had to accept that they would be predictable targets for German gunners. The responsibility weighed heavily. Behind them flew dozens of bombers carrying hundreds of men, all depending on the pathfinder to guide them accurately. A mistaken navigation or a miscalculation in the bombing solution wouldn't just mean missing the target. It could mean leading the entire formation astray. The bombardiers in the Droop-Snoots carried an equal burden. They worked in isolation, separated from the pilot by the bulk of the nose section. Communication happened through the intercom, but the roar of the engines and the crackle of static made every word a challenge. During the bombing run, the bombardier was essentially alone with his sight and his calculations. He had to identify the target through breaks in the clouds or on his radar scope, had to compute wind drift and ballistics, had to time the release perfectly, knowing that hundreds of bombs would follow his lead. The weather itself remained the constant adversary. European weather systems were complex and unpredictable. Forecasters did their best, but conditions could change rapidly. A mission planned for partial cloud cover might encounter solid overcast. Clear skies predicted for the target area might be obscured by unexpected fronts moving through. The Droop-Snoot crews had to adapt on the fly, making decisions in real time about whether to continue the mission, search for breaks in the clouds, or abort and bring the formation home. Some missions pushed the limits of what was possible. Pathfinders would lead formations through multiple cloud layers, navigating by instruments and dead reckoning, breaking into clear air with just minutes to locate and identify targets. The bombardier would have to work fast, lining up his sight while the pilot fought to hold the aircraft steady in the turbulence that often accompanied weather fronts. Behind them, the bomber formations would emerge from the clouds, crews grateful for the clear air, but anxious about the flak that could now reach them accurately. The psychological aspect of Droop-Snoot operations shouldn't be underestimated. The bomber crews had to place absolute faith in the pathfinder. They couldn't see what the Droop-Snoot bombardier was seeing. They couldn't verify his targeting solution. They simply had to watch for his bombs to drop and toggle their own releases immediately. This required trust built through repeated missions and proven results. When a Droop-Snoot crew consistently put bombs on target, the bomber formations followed them with confidence. When results were poor, doubts crept in. German intelligence worked to understand the new threat. Reports from the front mentioned American fighters leading bomber formations, but the full significance took time to recognize. The Germans had their own pathfinder systems, so the concept wasn't revolutionary. What surprised them was the execution. Using a fighter aircraft as a pathfinder was unconventional. The speed differential created coordination challenges that German planners assumed would make the system impractical. But the Americans made it work. Luftwaffe fighter pilots adapted their tactics. They learned to watch for the distinctive Droop-Snoot profile at the head of American formations. If they could shoot down the pathfinder early in the attack, the bomber formation would be disrupted. Bombardiers in individual bombers could still drop their loads, but accuracy would suffer without the coordinated release. German pilots took risks to get shots at the Droop-Snoots, sometimes flying through their own flak to reach the pathfinders before they could complete their bombing runs. The Droop-Snoot crews developed counter-tactics. Some missions used multiple pathfinders, providing redundancy in case the lead aircraft was damaged or destroyed. Others varied their approach patterns to make interception more difficult. Fighter escorts received instructions to provide extra protection to the pathfinders, recognizing their critical role. The dance between attackers and defenders played out at 25,000 feet over targets that neither side could see through the clouds below. By summer 1944, Droop-Snoot operations had become routine. The 20th Fighter Group had been joined by other units flying modified P-38s. The technique had proven itself sufficiently that production P-38s began incorporating provisions for the bombardier nose modification. What had started as a field expedient had become standard operating procedure. The 8th Air Force could now prosecute its bombing campaign regardless of weather conditions. The impact on the strategic bombing campaign was significant. German industry had counted on weather to provide periodic breaks from the relentless American attacks. Those breaks disappeared. The winter months, traditionally a period of reduced operations, saw continued bombing thanks to pathfinder techniques. German fighters and flak could still exact a toll on the attacking formations, but they couldn't count on the weather as an ally anymore. The Droop-Snoot represented a particular kind of innovation. It wasn't a technological breakthrough. The components already existed. The P-38 was in production, the Norden bomb sight was standard equipment, and pathfinder techniques were understood. What made the Droop-Snoot significant was the willingness to combine these elements in an unconventional way. Someone had looked at the problem of weather and bombing accuracy and thought beyond the obvious solutions. Instead of waiting for better weather or developing new technology, they adapted existing tools in creative ways. The modifications required to create a Droop-Snoot were substantial but not revolutionary. Remove the guns and ammunition from the nose. Install the bombardier station with its plexiglass nose cone. Add the Norden bomb sight and its associated equipment. Modify the internal communications to connect the bombardier and pilot. Install bomb racks to carry the Pathfinder's own ordnance. Each change was straightforward, but the combination created something new. A fighter that could think like a bomber, lead like a Pathfinder, and survive like a fighter. The success of the Droop-Snoot program validated the concept of specialized variants. Not every P-38 needed to be a Droop-Snoot, but having some available gave commanders flexibility. When weather threatened to scrub missions, pathfinders made them possible. When cloud cover protected targets, pathfinders penetrated it. The relatively small number of modified aircraft had an impact far beyond their numbers because they enabled the larger force to function effectively in conditions that would otherwise have grounded them. After the war, the lessons from the Droop-Snoot program influenced how the military thought about aircraft specialization and pathfinding. The concept of using fast, maneuverable aircraft to lead larger, less agile formations proved applicable beyond World War II. Modern military aviation includes specialized variants of standard aircraft designed for specific missions, carrying forward the principle that the Droop-Snoot embodied. One aircraft leading many, using speed and capability to overcome obstacles that would stop the formation. The Droop-Snoot P-38s never achieved the fame of other Lightning variants. The photo reconnaissance versions that flew alone over enemy territory, the night fighters that stalked in darkness, even the standard fighters with their guns blazing, all captured more attention. But the Droop-Snoots did their job without fanfare. They led formations through weather that should have stopped them. They put bombs on targets that should have been unreachable. They proved that sometimes the solution to a problem isn't new technology or different tactics, but creative adaptation of what already exists. The bombardiers who flew in those modified noses, lying prone while their aircraft raced toward targets at 300 miles per hour, deserve recognition. They worked in cramped quarters, dealt with vibration and noise, made calculations while flak burst around them, and bore the responsibility of guiding entire formations. The pilots who flew those missions, suppressing their fighter pilot instincts to hold steady courses through defensive fire, demonstrated discipline that training alone couldn't instill. Together, they made blind bombing possible when weather should have provided sanctuary to their targets below.